this is going to close out quarter number 3. We're going to go over natural logarithms and the number e. So first off, there's also a little bit of review in here. The compound interest review question. This will show up on our benchmark test. So there's just a quick warm-up question right here. There's the formula. We are investing $7,000. So that is our initial principal. Our rate in this problem is 7%. So remember, first what you need to do is you need to divide 7 by 100 before you put it into the formula. And that gives you 0.07. Remember, n is not 100. N is the number of times the interest is compounded upon itself. And since it's compounded quarterly, quarterly means 4 times a year. So 4 goes there, and it goes into the exponent. And then t is our time, 11 years. And then you just type that in the calculator exactly like it looks. So our final amount is $15,000, $15,018, plus a little bit of change. So the one formula we did not go over is what happens when the compound or the interest is compounded continuously. So we've talked about quarterly, annually, daily. When it's compounded continuously, like moment after moment, every moment that interest is added into your account, there's a different formula. It's actually a little bit of a more simple formula, but A is still the final amount, P is still principal. E is a new one though. E is a lot like the number pi. This shows up a lot in the financial world. It's just kind of a common scale factor you see in business problems. But if you look, E is actually a button on the calculator. You can find it in 2 different places. The place I usually go to is second division side. And then when you hit E, you can see the decimal. So there's a lot of talk about pi. But E, especially again in the financial world, is actually a more useful number. And you can see it shows up as a common scale factor for this continuously compounded interest formula. So we're going to use this formula for number 2. And again, we know we can use it because the word compounded continuously is used. So $7,000 is our initial principal. E is just a constant number. We already know 7% is 0.07 from the previous problem, and time is 11. And then again, we just type this in exactly like it looks. We talked a lot about applications in the stock market, about these interest problems, and this is just another tool, another formula that is used. So there's our final amount, $15,118.36. You can see something that's compounded continuously. This is something you want when you invest in the stock market, because you're going to get interest added onto your account more often when it's compounded continuously rather than compounded quarterly or daily, anything like that. Try the next one on your own. There's the setup. And then there's your final answer. Pretty good chunk of change. Of course, we invested $12,000 and they kept it in there for 15 years. So that's why it's come out to be such a big number. So over $43,000 and about 32 cents. All right, and the final thing we're going to talk about, this is also, again, more review for the benchmark test. We're going to review logarithms, and then we're actually going to look at one new type of logarithm that we didn't discuss back in January. But you should know the answer to this first question. We know standard logarithms have a base of 10 if it's not given. And if you recall, this is logarithm form and exponential form. And you remember using the swirly method to go from one form to the other. And that's what we're going to do in these couple examples. We're going to convert from one form to the other and just kind of review this process. So again, number one, there's no base given. So I'm going to insert a tiny little base of 10 right here. I'm going to go in, number two already has a base. So remember, the swirly method is this. You take the base, you raise it to that number, and then you set it equal to that. Now, of course, we could solve this with the directions say just convert to exponential form, and that now is in exponential form. Same idea on this other one. The base is 5. It's raised to the x power. So we're just using the swirly method, and it's equal to 50. So hopefully that's coming back to you just a little bit. So natural logarithms have a base of e. So that number shows up again. So remember, logarithms, we talked about earthquake problems. We talked about populations growing very rapidly. We used logarithms for both those types of problems. Natural logarithms, we're talking about big money, basically. So when you have a lot of money, use natural logarithms. But these are really basic. They work exactly like a standard logarithm, except the base is different. So the directions here say convert from log to exponential form. Again, do not solve. So number 3, no base is given. So it's e, the number e. Remember, that is a number in the calculator. So 3 and 4, I inserted the base, and now I'm going to do swirly method. So it's e raised to the x power equals 6. So we're just manipulating these equations, writing them in a different form. Same thing on 4. Take the e, swirl it to the 3, that's the exponent, and then you're going to set it all equal to 2x minus 5. And again, you could solve this one right here. E to the 3rd, you could type in the calculator, which we're going to do here in just a second, but this one does not want us to solve. We all are, however, going to solve 5 and 6. I'm going to give them both a base e. Remember, anytime they give us a natural log, we're going to do swirly method to convert it. Now, e to the 3rd, we can type in the calculator. And we get approximately 20.0855. And then, of course, just add 1 to both sides. So x is equal to 21.085. So again, not a whole lot to this. Last one, the base is e. Remember, anything raised to the 0 power. If you do not know, that is a great reason why we have the calculators. So I don't know what it is, so I'm going to type in the calculator, anything to the 0 power. Look at there, it's 1. So 1 equals 2x, divide both sides by 2. X equals 1/2 or 0.5.